Okay, on page, oh, this is, okay, on third period. Look, on page 212. Give it time to kind of warm up a little bit. Okay, let's kind of review what we talked about on Friday. Angle similarity. Who remembers what that tells us? Angle similarity. Look at the top. What? Well, angles can't be similar. Angles either are congruent or they're not congruent. It tells whether triangles are similar, right? So, Logan, tell me, if two triangles are similar, what do you know? What's the same? Well, every triangle, it might not be triangles. It might be rectangles or squares or something. So that's not, Willie? The angle measures are going to be the same. When two triangles are similar, all three angles in one are going to correspond to all three angles in the other. Right? But you only have to worry about how many of them? Two. Angle. That's why it's called angle similarity. When you can find two pair of congruent angles in two triangles or two figures, then they're going to be similar, right? And I want to do something up here that I didn't do Friday. So the triangle ABC is similar. Everybody come over here. Triangle DEF and write it up there. Those two triangles are similar. So what you know is that angle A corresponds to angle D, and angle B corresponds to E, and C corresponds to F. That means A and D are congruent. Now this helps you when the figures are turned like crazy. That's what helps me to match up the angles. That's very, very good. And it also helps you to measure match up the corresponding sides. Like AB is going to correspond to DE, and BC to EF, and so on. That's really comes in handy when they start turning the figures and they don't look the same. Okay? But you just have to worry about two angles that match up to two more angles. Okay. Then number 2, we learned how to set up a proportion when you have two similar triangles. You can set a proportion up. So we did a 5.5 over 7.5. That was the height over the base of the little triangle, and then the height over the base of the bigger triangle. Remember, we had to add those together or look in our problem. Then the crisscross. That's what some people have not remembered this morning. The crisscross. I don't know 7.5 times what is 23.5. I do not know that. So I had to criss 7.5 times H equals 5.5 times 23.5. I had to criss, cross. And see the big X? That reminds you you're multiplying. Then we divide by 7.5. We got that. We rounded to the nearest 10th. Does everybody remember that? So we're good on all of that. Okay. Now look at the two parallel lines. And there's a transversal. There's two transversals that intersect. So what we're trying to find out is if the two triangles are similar. Okay, we're trying to prove. So one thing we proved is that BAC, this is where we were when the bell rang, that BAC is congruent to EDC. And that's what we were about to explain. We're looking at this transversal. How do we know these two angles are congruent? Let's play Wheel of Fortune.
Interior. Yeah.
Why are they alternate interior?
They're both on the inside.
And look, abbreviating. Look, here's the two parallel lines. That's the interior right there. Both angles are on the inside of the parallel lines. And they're on the opposite side, the alternate side of the transversal. So we know that this, put one little line through it if you, I've marked over mine so much it's going to be hard to see. We know that that angle is going to be congruent to that angle. Okay? So we've got one pair of congruent angles. Now let's see if we can find another one. ABC, this one. And then angle DEC, DEC, right here. So we're trying to prove that that and that are congruent. Are they?
Yes.
Why?
The vertical.
No, they're not vertical. This and this are vertical. Those aren't vertical. Are they? No, they're not right across from each other. They're interior. They're on the inside of the parallel lines. And what? Alternate interior angles again. So we have discovered that two pairs of corresponding angles in the triangles are congruent. So what do we know about the two triangles? They're similar. So by the angle similarity, and we're not going to put postulant on there, just by angle similarity, triangle ABC and triangle DEC are similar. We proved it because we found two pairs of corresponding angles that were congruent. True?
True.
Are there any questions on this? How to set a proportion up? You think you got that? And how to do the crisscross? Okay. Look at page 213. Okay, I'm going to show you how we want this written. On number 5, don't go ahead and start it. Just listen and write down what I'm telling you to write down. Write down, excuse me. So we're finding the missing angle measures in the triangles. So on this triangle, what do we need? Measure of what? Angle B. In a minute, you're going to do that. The measure of angle F on the next one. Then we need the measure of angle H on the next one, huh? Don't we have I? Yeah, we have I. That's okay. And then on the last one, we need the measure of angle K. On 6, it says which triangles are similar. So we're going to, don't start, please. Don't start, please. I already said that. Don't start. On number 6, which triangles are similar? So you're going to put triangle, and you're going to tell me which are similar. How do you name this triangle? ABC. That's DEF, GHI, JKL. So you're going to tell me this one triangle is similar to which triangle? And there might be another pair. I don't know. If there is, you put a comma and then you write the other ones. That's a similar symbol. I know there's at least two similar though. Okay, number 7, for some reason, some people have been confused on. It says determine which angles are congruent to the angles in triangle ABC. All you're going to do is angle A is congruent to angle, and you're going to tell me which other angle it's congruent to. Is it congruent to G or K or J? Whichever one. And then you're going to do angle B is congruent to which angle. And then angle C is congruent to which angle. That's all you're doing. Just telling which angle A, B, and C are congruent to. That's pretty easy. How do you know if they're congruent? They have the same measure. Pretty easy. Now look at 8. We are going, hey, look, put an arrow right here. We're going to do 8 right here. And then we're going to do 9 down here because we're not doing 10. Mark out 10. We're going to talk about 10 later, but I needed room to do number 9. Okay, look at number 8. It gives you a picture. You're going to set a proportion up. What should that proportion have in it? 3 numbers and a variable. Don't put your answer in there. I need to see 3 numbers and a variable somewhere. Okay? Now, number 9, I'm going to help you draw the picture because I got confused first period. So I'm going to help you. It's kind of tricky the way they worded it. Sheila is climbing on a ladder that is attached against the side of a jungle gym wall. So here's the jungle gym wall. Walls are always straight up, right? Okay. The ladder is leaning. The ladder is leaning. Oh, I should have put it. Oh, well. We're going to have room. No, we don't have much room to write. Okay. She is 5 feet off the ground. So she's not at the top of the ladder yet. She's on the ladder 5 feet from the ground. Wherever she is, she's 5 feet off the ground, which is 3 feet from the base of the ladder. Base of the ladder means the bottom. We're going to do Pythagorean theorem next, starting tomorrow. Well, Wednesday. And when we do that, we have to know, they want you to know what top of the ladder means, base of the ladder, how far the ladder is from the wall. We have several problems like that, so this kind of gets you ready for that. Base of the ladder is 3 feet. This is what was confusing. Which is the base of the ladder, which is 15 feet from the wall. So there's the wall. So that's 15 feet from there to there. Draw a diagram. We just did. How high up the wall is the top of the ladder? So top of the ladder, how high up the wall? So we're trying to find the height of the wall to the top of the ladder, huh? So you're going to set a proportion up. What do I want to see in the proportion? 3 numbers and a variable. And then solve. You might need to crisscross, or it might be easy enough where you go across and multiply like we did on page 209 and 210. Oh, wait, we have to do something before we do that. Okay, so everybody understand? We need to go back and look at something on 210 before we finish. Look at 210. Yeah, you're going to go back and do 213 in just a minute. So look at 210. What I need you to do is take your ID and draw me a line that's not horizontal. And that's going to be line L. Okay, it says put points A, B, C, D on it. A, B, C, D. Just put points A, B, C, D randomly on the line. Okay, now, I need you to take your ID and try to make a horizontal line through point A and go all and make it dashed. Horizontal line. Then we're going to do a horizontal line through point C. What would the slopes be on these two horizontal lines? 0. The slope is 0. Remember on horizontal lines? Slope is 0. So does that mean since they have the same slope, they're parallel? Yeah. Two lines that have the same slope are parallel. Remember, we learned that. I guess we forgot it. So these two lines are parallel. So what is line L? Transversal. Very good. That's the transversal that cuts through there. Everybody good so far? We know what we've drawn. Two parallel lines. Transversal. Now what I need to do is make a vertical line from that horizontal line up. We're going to draw a triangle there. And let's call this point, we've already used C and D, so let's call this point, let's call it F. Let's call it F. Okay? Doesn't really matter. And now on CD, let's come over there. And what are we doing when I go run horizontally, then go up vertically to that? That's the slope, isn't it? Let's call this E. Okay? We have made two triangles. Do they have the same slope? The two triangles? Yeah, they're going to have the same slope because look, that line right there is the slope of them. So these two triangles are going to be on the same slope. They're going to have the same slope. Does that make sense? Okay. So we're going to prove they're similar. We're going to prove these two triangles are similar. We already know that angle F and angle E are congruent. How do we know that?
They're both 90 degrees.
They're both not, because we ran and then we went straight up. So we know those are 90-degree angles. So we already have one pair of congruent angles. We already have one pair, E and F. Now let's talk about A and this one right here. BAF and DCE. That angle and angle. That angle. I'm going to tell you they're congruent. You tell me why. What's the reason they're congruent? Well, these are parallel. These lines are parallel. But what makes this angle and this angle congruent? No, they're not. They're corresponding. Look. Look. In that, look, see where these two lines intersect? Do you see the four angles? And then down here, the four angles? Well, that's the top right corner, top right corner. So, yes, they correspond. So, this angle and this angle are congruent. So, what do we know? Triangle ABF is similar to triangle CDE. F and E are congruent. A and C are congruent because they're corresponding. See the transversal? Here's the inside, so they're not interior angles. One is, but one isn't. Do we remember that now? Okay, now watch this. What has to go there for them to have the same slope?
4.
Oh, good job. So 2 over 3 equals 4 over 6, doesn't it? 3 times 2 is 6. 2 times 2 is 4. So see, they had the same slope. Look, guys, are y'all getting the connection here? They're the same slope, but they also have their sides. Their sides are proportional. Hey, is it all coming together, I hope, in your brain? Good deal. Any questions about that? Positive? Okay, turn to page 213. Okay, we're going to play catch up today. Everybody look at the board over there, third period. 4 people have not turned in that page 197 out of the book. And you remember, you have to attach a piece of your work paper to 197. When you turn it in, please go erase your name. When you turn it in, go erase your name. 139 should be turned in. 197, 213 that we just talked about. You're going to tear that out and turn it in. And then work on DD 3536, which is due when? Wednesday. Do not do the 8182 that's attached to it. If it was attached, you probably already unattached it. Madison. Go find it. Go over there and look for it. Oh, does everybody understand what you're going to do?
Yes, ma'am.
In that order. In that order. Do you turn everything in that's over there?
Yes.
If it's finished?
Yes.
Except 8182. 8182. Okay. Good deal. Get busy. And you may listen to your devices.